classless network into BGP, then it is mandatory to define your mask value, but this time you know very well that it's not required anymore. 100, 101, 102, and finally 103. And then you can see show IP BGP over here that we are having these 4 prefixes available over here at New York router. So it will advertise those, this New York router is going to advertise these 4 prefixes in the direction of BT, and then further BT will advertise it in the direction of Alpha R6 as well as Sprint US. Then definitely for Sprint US, its best path to reach all these prefixes will be BT. So Sprint will also tell to Alpha that you can also reach all these prefixes via me as well, right? So now because you have advertised all these prefixes at New York router, so definitely you must get them on all devices now where BGP is running. So here in this topology, I'm not running BGP on all routers. Let me show you that how have I configured, or how I have configured BGP in this topology, right? So I will let you know, but before that, let me do some modification over here. Like on R5, it's showing me CDP duplex mismatch, so simply I will say no CDP run, and do show run pipe section router BGP router BGP, it's using 65500. I have to remove some configuration from here, and this 56 is over. Only this configuration is available here on R5, that no synchronization is by default there in BGP, as I said earlier on. And the BGP log never changes. What does it mean? That it will generate a log message whenever a BGP neighborship will go up, or if it goes down, then also BGP will give you a log message. I hope that you understand it very well, that what is the meaning by BGP log. BGP log never changes. Don't you understand the meaning of this command? Do you understand it? Sure?
Yes.
Dinesh, what's the meaning of it? Exactly, on the console of the device, right? Like this time you are accessing this device with the help of console cable. So whenever you will be having the console of this device, and then if your neighborship, BGP neighborship goes down, then it will show you that message that neighborship has gone down with this neighbor. If BGP comes up, then also it will show you that message that with this neighborship have came up, right? So this time it is having neighborship with 1. This is the loopback of R1, and the loopback of this R1 is reachable via OSPF. As I have already explained you that internally we are running OSPF. So all routers are learning their loopback addresses with the help of OSPF, because OSPF 1 area 0 is already configured here among all devices. Hello, is there any problem? BGP is now also let you know how BGP is configured in this topology, but try to memorize that on all these devices, on all these 6 devices, we have configured OSPF so that all devices are learning each other's loopback addresses, loopback networks. As you can also confirm it here on R1, show IP route. However, some routes will be there which are learning through BGP as well. But apart from it, see, these are the loopback address of all devices. Here we are having 6 devices, 1, 2, 3, 4, 5, 6, R1, R2, R3, R4, R5, and R6. And you can see that we are learning each router's loopback address with the help of OSPF, because OSPF is running as a internal routing protocol over here. Understood? So basically here on R5 we can see that this configuration is there. It means it is having IBGP neighborship with R1, and also it is having neighborship with 200.105.100.1, which is the BT's IP address. This is BT's IP address, 200.105.100.1. So R5 is having neighborship with BT as well as with the Sprint. This is the Sprint address, as you can see in your diagram as well. 205.100.100.10. Understood? Understood?
Yes.
Fine. Then after on R6, if you move on R6 also I have to do some modification in its BGP configuration. I have to remove command for R2. I have to remove command for 56.5 as well. Now it is also having neighborship. See, this R6 is having neighborship with R1. See, remote AS update source loopback is also configured. Next stop self is also configured because this is IBGP neighbor for R6, right? For R6, R1 is what? IBGP neighbor, and you know very well that if you are receiving prefixes coming from EBGP neighbor, and then if you are giving those prefixes to your IBGP neighbor, then definitely what? Next stop addresses will never get changed automatically. See, there is a rule in IBGP that if you are giving an update to your IBGP neighbor, then its next stop address will never get changed. But if you want to change your next stop address, you have two options, either with using next stop self, but next stop self command can be configured only on edge routers. And then after you can modify their next stop addresses with using their route maps. So this time it is also having neighborship with EBGP neighbor BT. See, this is the BT's address 201.100.100.1, as you can see here in this diagram as well. This is BT and its AS is what? 35500. See, this is the command. And right now we have advertised prefixes into BGP on to New York router only. I'm not advertising any other prefix on any other router right now. So only on New York router I have advertised all these 4 prefixes, which are like 100.0/24, 101.0/24, 102.0/24, as well as 103.0/24. Have you understood it now?
Yes.
Sure. Now go back to R1 and you see everything is fine. Now you do one thing. See, this time BGP is not running on R2, R3 and R4. BGP is not running on R2, R3 and R4. I have not configured BGP. That's why I said that logical topology will be quite different from this physical topology. Right now what is happening, that R1 is having neighborship with R5 and R6, both of them. R1 is having neighborship with R5 as well as R6. As you can see, you can move on R1 and you can check it out. Show IP BGP. So it is having neighborship with 5 as well as. It means there will be a black hole here, because routes of course can go from R5, R6 to R1, but those routes will not be available on R3 and R4. But actually I don't need to ping. I just need to show you that how can you manipulate your BGP path selection with using BGP attributes. I will not see ping, of course, will never happen over here. Ping will never be successful over here, because for that you have to run BGP onto R3 as well as R4. Otherwise there will be a black hole. Of course there is a black hole right now, because neighborship is there in between R1 and R5 and of course R1 and R6. But BGP is not running on R3 and R4, and also you have not redistributed BGP into OSPF. That is why those routes will never present on into the routing table of R3 as well as R4. But traffic, whenever you will transmit any traffic from R1 in the direction of New York router, it has to go through R3 as well as R4. So once they will reach, your packets will reach R3 and R4, they will get dropped, because R3 and R4 do not have route to reach your destination, right? So of course ping will never be successful, but we just need to perform path manipulation, and that can be done onto R1 without any problem, because R1 is receiving prefixes coming from R5 as well as R6. Now see, R5 is having neighborship. See, your logical diagram is something like this actually. This is your logical diagram of BGP. This R1 is connected with R5 as well as, then it is connected with Sprint, then you are also having BT. This R5 is having neighborship with both of them, and then Sprint and BT are also interconnected, and then further New York router is connected with BT. So this is your logical topology. This we are running BGP in this diagram, in this at the end of customer only on these 3 routers, R1, R5 and R6. So BGP is configured in this manner actually. This is your logical topology of BGP. Tell me. So this time R1 is receiving these prefixes coming from R5 as well as R6. Now try to understand it now. See, First of all, this New York router will advertise these prefixes in the direction of BT. Then for BT, its best path to reach all these prefixes will be via New York router only. See, you are on BT now. Check it out. Its best path is via 81.1.10, and who is having this IP address? This 80.1.1.10. Of course, New York router. So for BT, its best path is via New York router. See, what is the meaning by this asterisk? Valid. What is the meaning of this greater than symbol? Is what? Best. So you must remember the meaning of these symbols as well in BGP, right? So I hope that you people understand this. The meaning of these symbols were very well. Like what is the meaning by asterisk and what is the meaning by greater than. So asterisk means it is what? Valid. Or even though you can also find over here the meaning of these characters. Like this is valid and this is what? Best. And this I is what? Internal. See, this I can be either in the beginning of the prefix or in the end of the prefix. So if this I is in the beginning of the prefix, it means it is an internal prefix. It is an means that it is coming from an IBGP neighbor. But if it is not there in the beginning of the prefix, see, like here it is not mentioned over here. It means there will be two possibilities. One, either it is received from its BGP neighbor or it is self-advertised. There will be two possibilities in which you will never find I in the beginning of the prefix. First one is what?
BGP neighbor.
It is received from an BGP neighbor. Second, self-advertised. As you can see, I is also mentioned in the end of the line as well. And if it is mentioned in the end of the line, it means it is specifying what? Origin codes. And I have also told you before that if you are advertising anything into BGP with using network command, its default origin code will be I. However, here by looking at the meaning of this IGP, so it says that okay, if route is learned through IGPs, then it will be containing its origin code as I, but it's not true. See, in BGP, if you are advertising anything with using network command, by default its origin code will be I. And if you are redistributing anything into BGP, then by default its origin code will be question mark. And these origin codes will always be mentioned in the end of the line. As here you can see that it is always mentioned in the end of the line. Tell me. Is there any problem now? Sure. Good. So now if you move on R1, even if you check it on R1, see, for R1 both of them are IBGP neighbors, right? So IBGP, see, it is receiving these prefixes coming from R5 as well as R6. And in the beginning of the line, see, there is what? I. And also in the end of the line as well. So if this character is mentioned in the beginning of the line, it means it is an internal prefix, and if this character is mentioned in the end of the line, it means it was advertised with using network command into BGP by default. However, you can also modify your origin code as well. That's quite different thing. Fine. Hello, you people tell me, have you understood it or not? See, if this I is mentioned in the beginning of the line, in the beginning of the prefix, it means it is an internal prefix and also received from IBGP neighbor. And if it is mentioned in the end of the line, it means, you understand very well now what I mean to say, right? So this time you can see that I'm on R1 and R1 is receiving these prefixes coming from R5 as well as R6. One more thing that I would like to show you. BT will advertise these prefixes now further in the direction of R6, R5 as well as Sprint. So of course for R6, its best path to reach all these prefixes must be via BT only. Fine. Then on R5, it is receiving these prefixes coming from, see, sprint as well as BT. See, if it is coming from sprint, then this AS 21545, see, 3 ASs are there. See, inside this is called AS path list. Under path, it will be what? AS path list. Means that it will show you that this prefix has already crossed these following ASs. So in this AS path list, BGP will always contain, tell me what? All those ASs to whom it has crossed.
Yeah.
Right? So of course, remember that inside AS path list, rightmost AS will be originating AS. Will be originating AS. The rightmost AS in AS path list will indicate that this is originating AS. Means that actually prefixes are originating from this AS. Right? And the leftmost AS will be your neighbor AS. Will be your neighbor AS. So this time in neighbor AS you can see there are two ASs. One is 21545, which is configured on sprint. I mean sprint is using this AS. So if you are getting prefixes, if you are receiving prefixes here from sprint, then definitely the leftmost AS will be 21545. And also you are receiving these prefixes coming from BT as well. And from BT, of course, it is what? 35500. Fine. Okay. Now, as I said that whenever you will receive any prefix, okay, forget about all these things. Now, let's start it from R1 itself. See, for R5, it will define its best path. So, for R5, which path is the best path here? Via BT. Because via BT it has to across only 2 ASs, whereas via sprint it has to across 3 ASs. So its best path is via, yes, tell me. Who? R5? R5 and R6 do not have BGP pairing with each other. See, this is your diagram now. Fine. So R5 and R6 do not have direct neighborship with each other. R5 and R6 are having neighborship with R1, IBGP neighborship with R1 only. And R1, of course, by default in BGP there is a IBGP rule that if you are receiving anything from your one of the IBGP neighbor, then you will never advertise it towards any other IBGP neighbor. So that definitely R1 will be receiving prefixes coming from R5, but will never advertise it in the direction of R6. And also if it is receiving anything from the R6, then definitely it will never advertise it in the direction of R5. Have you understood it or not? Great. Now let's move back again on R1, and you can see here. And remember that BGP will always advertise only and only best path information. That is why here it is receiving this information from R5 that you are required to across only 2 ASs, not 3 ASs. Because for R5, its best path was via BT only. See, this is the best path for R5. So it is advertising only and only best path information. See, in BGP, this feature is contained from distance vector routing protocols, that it will advertise only and only best path information towards its neighbors. So for R5, its best path is via BT. So only this best path information is propagated from R5 in the direction of R1. Check it out. And from R1, which path is the best path? Via R5. As you can also see, show IP route via BGP. See, all for all those prefixes which have learnt here via BGP, its best path is via R5, not via R6. That's completely incorrect. Now, in terms of R1, I will define you, or I will teach you that how to perform path manipulation in BGP, right? I will start from very scratch. I will start it from next hop address configuration first of all, right? And then I'll go for some other things, some other configuration. Fine. Just yes, guys. For R1, its best path is via R5. So first of all, I'll teach you that why R1 have selected its best path via R5. Fine. So let's start it now. So IP BGP. See, this is your one path, and this path is coming from R5 as well as R6. The very first thing that is checked by BGP is that whether this path is valid or invalid. So both of them are valid. See, this is. Then second number will be next hop address. Why R5? Its next hop is what? The loopback of R5. Why R6? Its next hop is what? The loopback of R6. Because I have configured that next hop self command onto R5 as well as R6 for their neighbors, for their neighbor R1.
Validity the next hop के base पे होता है.
No, sometimes it is not like that. I'll let you know later on that in which conditions it will not be valid actually. See, if I move back again on R5 and see, this is the existing configuration of BGP onto R5, right? And this is router BGP 65500. Now I'll simply remove this next hop self command from here, and in same manner I will move back again on R6 and let me show you the existing configuration of BGP onto R6. And onto R6 itself, what will I do actually? 65500. I will remove this next hop self command only. After removing these two commands from R5 as well as R6, now let's move back again on R1. So if you are on R1 now, you see next they are valid paths. I mean, these prefixes are valid, but they are not best. So basically, this valid or invalid will not be depending on your next hop address. Remember all these things, right? So still these prefixes are valid but not best. I'll let you know later on that in which conditions even your prefixes will not be valid prefixes, right? So I will teach you all these things as well. But this time you can see that due to next hop reachability, it's not, I mean, no one is best. Now, if you move back again on R6, this time I'm on R6, right? Router BGP 65500 for their neighbor, I mean for its neighbor 150.1.1, I will say next hop self. Once you will configure this command onto R6 now, you see its best path have been configured via R6. So what is it checking first of all? Next hop address. See, this time via R5 it's not participating in best path selection. You know why? Because its next hop address is not reachable anymore. Even you can also try to communicate with 200.105.100. Of course it's not reachable from here. But if you try to communicate with 150.1.6.1, it is reachable via OSPF, because internally I am running OSPF and this is the loopback address of R6. Even I have configured BGP peering between R1, R5 and R6 with using their loopback addresses only, right? So now you do one thing, move back again on R5 as well. Say router BGP 65500, and as you remove from here this next hop self command, now once again reconfigure this next hop self command here onto R5. Now move back again on R1 and check its BGP table. See, see,
जब नेक्स्ट हॉप जब रीचेबल ही नहीं फिर उसको वैलिड क्यों रहता है?
मैंने कहा ना, मैं बाद में बता दूंगा किस केस में इनवैलिड होगा. अब वैलिड के पीछे पड़ जाना बस. So I hope that you people have understood all these things, right? So see, once again its best path is via R5. Now question is that why has it defined its best path via R5. Like for R5, its best path was via BT. Reason was AS path. Because via BT it was required to across only 2 ASs, whereas via sprint it was required to across 3 ASs. So R5 defined its best path via BT due to AS path attribute. But this time, if you move on R1, its best path is via R5, and you have to identify it that why has R1 defined its best path via R5 only, not via R6. First of all, you will check what? The sequence. In sequence, tell me that what will you check first? The very first attribute is what that BCP checked first? Next hop reachability. So of course, via R5 as well as R6, its next hop addresses are reachable. Next is what?
Yes.
Wait. After next hop, it is wait that you will check first, right? So hey, I have also defined you that in which sequence BGP will check its attribute. Don't go for that. I mean for the categories of attributes. Check it out. Where is it? Next. Where is that? You didn't mention it here.
Next stop is
See, first of all, it is weight. Next is what? So, okay, first of all, let's talk about the weight. See, as I told you,
wait.
that first of all, it will check its weight, and for all received prefixes, by default, its weight will always be 0. So, via R5 as well as via R6, its weight is what? You can see here. So, based on weight, it is not going to decide its best path now. After weight, it was local preference. Fine. Higher is always preferred, but you can see for all internal prefixes by default its local preference will be 100, and here you can see that by default its local preference is 100. Check it out.
Yep.
And because its default local preference is 100 via both neighbors, so of course it is not going to define its best path based on local preference now. Next attribute was
Self-advertised.
it is not self-advertised. These prefixes are coming from its neighbors only, right? Is it self-advertised from R1?
No.
Of course no. It is received on R1 from its neighbors R5 as well as R6. Next is what?
AS path.
AS path. Now it will calculate total number of ASs available inside their AS path list, and here you can see that via both neighbors it has to across same number of ASs. Is not it? It means R1 it will not be able to define its best path based on AS path attributes. So that's why it have not elected its best path yet. Next is what? IGP codes. I mean origin code. Don't say IGP code, say origin codes. So via both neighbors its origin code is what? I, which is again equal. It means that based on origin code again this BGP is not going to define its best path selection. Next is what? Med. Higher is always lower is always preferred. Lower is always preferred, and by default for all internal prefixes it is what? 0, as you can see here. By default it is 0, and if it is 0 via both neighbors again based on med, it will not be possible for BGP to define its best path. Next is what?
IGP cost to reach.
IGP cost to reach?
Next
stop.
stop.
No, it's not. Before that we are also having external is always preferred over internal. But this time you see that I is mentioned via both neighbors. Check it out. In the beginning of the prefix. In the beginning of the prefix I is mentioned, not in the end of the line. In the beginning of prefix itself I is there. It means it is an internal prefix which is received from an IBGP neighbor. So this time this R1 is receiving these prefixes coming from an IBGP neighbor. That is why this I attribute is there. I mean not I. Yes, of course it is I origin code, right? This is IGP origin code, right? Via both neighbors. So because via both neighbors its origin code is same now, will it be possible for BGP to define its best path based on origin code now? No. Next attribute will be
IGP cost to
wait. After origin code I taught you external internal actually.
med.
Okay, after origin code it was med, and then after med I taught you external internal. So for external internal you will not see that I which is in the end of the line. No, you have to see that I which is in the beginning of the prefix itself. So if there is I in the beginning of in the beginning of the prefix, it means it is an internal prefix. It is received from an IBGP neighbor. So via both neighbors there is I, because both of them are IBGP neighbors. So this time R1 is receiving this prefix from internal, from an IBGP neighbor. That is why based on external and internal, it will not be possible for you to define your best path. Hello, this time this router is not defining its best path selection based on external and internal. Next is what? IGP cost to reach next hop. Now, there will be two conditions. Either IGP will be running over there or not. Is not it? So this time you are running IGP, I mean OSPF. This time the meaning by IGP cost to reach next hop address is the actual IGP cost actually, like OSPF or EICRP or RIP, whatever it is, right? So this time we are running here OSPF to reach next hop addresses. So what is the cost to reach the loopback of R5 and what is the cost to reach loopback of R6? To see that, you do one thing, say so IP BGP 100.0, so that it will show you detailed information. Now it will show you it will show you information, it will display information in more details. See, via R5 its metric is what? To reach this this R5, and to reach R6 its metric is what? So its lower metric is via
R5.
That's why its best path is now via R5. And if you want to prove it, we can prove it actually. See here what is happening actually in this diagram. This link is of 100 Mbps. This link is of 10 Mbps. So the default cost of loopback interface is 1. The default cost of loopback is 1, and the default cost for 100 Mbps will also be 1, and default cost for this 10 Mbps will be 10. So 1 is for loopback, 1 is for this 100 Mbps, and then 10 for this 10 Mbps link. Total cost will be 12 to reach R5. Because if it goes, you see, R1 can also reach the loopback of R5 via R3 as well as via R2, but the shortest path will be this. Because here you are having Ethernet connections, whereas for serial interfaces by default cost is what? 64. That is why for R1 its best path to reach the loopback of R5 will always be via R4. R1 will go to R4 and then R4 will send that information in the direction of R5. But to reach R6, see, both links are serial links. That is why cost is higher to reach the loopback of R6 from R1. You see? So this time it is here its cost is what? 64 here. So 64 plus 1 plus 10 is what? 75. Hello. Even you can also check it on R1 as well. So IP route OSPF. Check it out. 75 and 12. Any problem? So now that is why for BGP its best path is via, check it out, R5. Done. Now to solve this or to prove it, what can we do? We can configure here its cost on F2 by 0 as 65 actually in place of 1. On R4 I will modify its cost of OSPF, right? So that the overall cost from R1 to reach the loopback of R5 will get changed. Now it will become higher than via R6, but you have to do this configuration at the end of R4's F2 by 0, because if you move on R1 and if you change it on R1's F0 by 1, then it will get changed for both networks, for the loopback of R5 as well as for the loopback of R6. So you have to do this modification in that manner so that the effects will be only for the loopback of R5 only. Fine. See. Oh, we have not made any change on R4 yet. So go to F2 by 0. IP SPF cost is what? Make it 65 now. Here. Now you move back again on R1. Check it out. Just wait, it will take some time to synchronize. See, why R5 its cost is what? And why R6 its cost is what? Which one is best now? Via? Tell me. Is not it? And if it is also same, then what will happen? Let's make it same now via both neighbors. Let's move on. R4 F2 by 0, make it 64 itself. So let's move back again on R4 and configure its cost is at 64 now. Move back again on R1. Open. Just wait for a moment. Via R5 also its best path will become via S75. See. So this time ICP cost to reach next hop is also same. What is next tiebreaker now? Oldest path. But this oldest path works only for EBGP neighbors. This time R1 is having exactly. R1 is having only and only IBGP neighbors, not EBGP neighbors. So this oldest path tiebreaker will work only in that case when you are receiving prefixes from your two different EBGP neighbors. But this time, of course, it will not take place, right? Next is what? Lower
router ID of
See, its best path is via R5. You can see here. So who is having lower router ID, R5 or R6?
R5.
How can you see here router ID? How can you see your router ID? Because this time next hop addresses as well as router ID is common. So how will you be able to see that what is your router ID and what is your neighbor address? See, remember, I'm again telling you, this is your next hop address. This is what? Next hop. And this is the metric to reach this next hop, right? Then this is your neighbor address, this one. This one is your neighbor address. And this is your neighbor's router ID in brackets. In same manner here, this is next hop. This is the ICP cost to reach next hop address. This is your neighbor address and this is your neighbor's router ID.
So what it will happen if you put same router ID?
Yes. Next is what? Lowest neighbor address. So now do one thing to prove it actually. See, this time based on lower router ID, it has defined its best path via R5 because R5 is having lower router ID than R6. Compare it. Hello.
Yes.
Of course, R5 is having lower router ID. You do one thing, move on R6, configure its router ID lower than R5.
Then R6 will be lovely.
Configure its router ID lower than R5. So let's move on R6 now and say BGP router ID. This is the command to configure BGP router ID, right? And make it 6.6.6, which will be lower than 150.1.5.1. Now move back again on R1. Let it synchronize first. See, its best path is now via R6. Check it out. Hello. Of course, based on lower router ID, it has proved now, right? And then after proving this mechanism of router ID, let's go for lower neighbor address, right? So for that purpose, I have to configure same router IDs on both devices, right? So let's do one thing. Because on R5 its router ID is 150.1.5.1, let's configure the same router ID on R6 as well. Let's move back again on R6 and say BGP router ID is 150.1.5.1. So this time for R1, both of them are having same router IDs, R5 as well as R6. And now you can see that best is via R5 because R5 is having lower neighbor address than R6, and it cannot be same. Two different neighbors cannot have same IP addresses. Can they have?
No.
Tell me. So this is the BGP path selection process. So finally decision is made based on
neighbor router.
exactly. See, this is the way in which BGP selects its best path. Fine, that was good. Now let's talk about BGP path attributes. I mean, let's manipulate path selection with using BGP path attributes, and I'm going to start it from wait. This is customer actually R1, and this customer is having two different customer edge routers, R5 as well as R6. The whole traffic is going via R5 now. However, let's do one thing. Let's change the router IDs now. Let's move on R6, and on R6 let's make it 6.1 itself, right? But again, you will see that based on router ID, again the best path for R1 will be via R5 only. Just to see via R5 for all prefixes. It means if you check its routing table, so IP route BGP, see its best path is what? I mean, its best path is via R5. Right? This is the problem. This is problem actually. You know how? Because if you are having two different connections actually, like you can reach internet via R5, you can reach internet via R6 as well. But your entire traffic, your whole traffic is going via R5 only. There is no load balancing actually. Are you getting my point or not? And one more thing that I would like to show you over here before going to modify it to wait. Let's move back again on R6, and for R6 it is learning prefixes coming from BT only. Is not it? In case if R6 lost its reachability with its neighbor, you can shut down your neighbor in BGP, right? That's called graceful
Shutdown.
and this feature now they have introduced in OSPF as well, but in iOS 15 only.
Version.
I discussed it with you. So now it has gone down. It should have received these prefixes now via R1. Is it receiving these prefixes coming from R1 now? See, that's the problem now. There is no advantage of having redundant link. How will you solve this problem? And this is your logical topology now. See, now you have two solutions: either configure IBC peering in between R5 and R6 as well. That's not allowed over here. However, you can configure it, but it's not allowed. So what will you do now to solve this problem? Are you getting my point or not? Have you understood the problem or not? See, R6 has lost its internet connection. Now the lane users behind R6 are not capable to reach internet. However, it should have reached internet via R1, because R1 is receiving prefixes coming from R5 and R6 is still having neighborship with R1. So R6 should have reached internet via R1, but it cannot due to IBGP rule. Due to IBGP rule. So to solve this problem, what can you configure? You can configure this R1 as route reflector. So you do one thing, configure this R1 as route reflector and configure this R5 and R6 as a client. So of course now route reflector can exchange prefixes in between two different clients. So do one thing, move back again on R1 and configure router BGP 65500, say neighbor 150.1.5.1 and then neighbor once again 150.1.6.1. And now see, move back again on R6. On R6 show IP BGP sorry, neighborship have not came up yet. Still it is in active state with R1, right? Just wait for a moment. Now it have came up, right? And you see show IP BGP. It have also received all these prefixes coming from not from R5. That's the problem. Prefixes are coming actually from R1, but next hop is unchanged.
Because IG.
Hello, that's the another rule of IBGP, that whenever a BGP router will advertise any prefix towards IBGP, it will never update its next hop address. And this time next hop self command cannot be configured on R1. Even it is not required. And this is good for us actually, that it didn't modify its next hop address. That's good. See, as I said previously in BGP when I was explaining to you that this is actually good feature. This is one of the good feature of BGP, that for IBGP it does not modify its next hop address. And now I will prove it, that why is it good for us that BGP do not modify its next hop address for its IBGP neighbors only. See, its next hop address is still what? R5's loopback. And internally you are running what? IGP. So whenever you will try to transmit traffic in the direction of 100.0, it will not go via R1. It will not go via R1, it will directly go in the direction of R5. See, this R6 has installed these prefixes inside its own routing table. So whenever it will require to transmit data towards all these prefixes like 100.0, 101.0 or 102.0 or 103.0, it will directly transmit that traffic in the direction of R5 now. Traffic will never traverse via R1. Traffic will never go via R1. However, this R6 is receiving these prefixes from R1. Try to understand. R6 is receiving prefixes coming from R1, but traffic will be forwarded towards R5 due to next hop, because remember, your router will always transmit your data based on next hop address only, because router always performs routing lookup in its routing table just to know its next hop address. It's not it. So this time whenever from R6 you will try to reach an internet, your traffic will go directly in the direction of R5. It will never go via R1. This is the advantage of do not modify next hop address by BGP for its IBGP neighbor. Have you understood it or not? If IBGP would have modified its next hop address, what could have happened? Traffic will start to go in the direction of R1, and then R1 will send it back in the direction of R5, and unnecessarily latency will be higher. Your bandwidth consumption will be higher. Understood or not? Because in BGP you can form neighborship in between two indirectly connected devices. That's what happening here actually, that R1 and R6 are having neighborship. However, they are not directly connected, but IGP is running over there. See, next hop must be reachable. So from R6, of course, R6 can easily reach the loopback of R5, because when R1 is giving these prefixes, see, move on R6 actually and open. However, by looking at this BGP table, it looks like it is getting these prefixes coming from R5 only, right? But if you open it in more details, 100.0, its next hop address is this, coming from neighbor this, and this is the neighbor's router ID. Understood or not? Do not read originator cluster list. We'll be discussing it later on during the advanced router factors actually. Right? Now, in case if neighbor comes up once again now, neighborship will come up, and once again this R6 will start to receive these prefixes coming from, check it out, R1 as well as BT. Now, its best path is via BT. Check it out. Why? Again, you have to discuss it with me. That why this R6 has defined its best path via BT only, not via Esprit or something else. First of all, what will it check first? Next hop. Whether it goes via BT or via R5, next hop addresses are reachable. You can try to ping it. Like 150.1.5.1 as well as ping 201 100.100.1. See. So next hop addresses are reachable now. See, next is weight is, tell me, will it be possible for BGP to define its best path based on weight now? Tell me. No, because it is 0, same. Next attribute is what? Local preference. No, it is not same. Via BT it is null.
Yeah.
Whereas via a BGP neighbor R5 it is what? 100. Remember, always remember that if you are not receiving any local preference, I mean if your local preference is null from one of the neighbor and from another neighbor it is receiving default local preference, then also it will not consider local preference, or it will not define its best path based on local preference. If it was happening, I mean if it was considering the local preference, then of course it should have selected its best path via R5 only, not via BT. Remember that if local preference is nothing, is blank, then also BGP considers it as 100. Actually it considers it as what? 100 if it is blank, if it is not mentioned. So by default it will consider it as 100, and now via both neighbors it will be what? 100. So it will be same. See, try to understand this local preference in this manner. Like if you are receiving default local preference from one of the neighbor, and from another neighbor you are receiving null local preference, nothing, then it will not compare its local preference. That's it. That's what I wanted to show you, or I wanted to tell you, right? So this time from one neighbor it is receiving 100, which is default local preference. From another neighbor it is not receiving anything, so it is not gonna to compare their local preferences for their best path selection. Because as I said, that if it is not receiving any local preference from one of the neighbor, then it will also consider it as 100. So actually it will become same. It is not like it is not considering local preference. It is considering, it will consider it. But do one thing, via R5 make it 101 now. Via R5 make it what? 101. Okay. Whereas via BT its local preference will remain as null. Okay. But you will see that it will start to preferred via R5. Okay. Because what I said, that if it is null, it will consider it as 100 only. So this time it is not possible for BGP to define its best path based on local preference. Next will come as AS path attribute. Self-originated, forget about it, right? AS path attribute. Via both neighbors, it has to across two ASs only. So of course, it's not possible for BGP to define its best path based on AS path attribute. Next is what? Origin code. Is I, same, via both neighbors. See, after AS path. Then med is also same. Via one neighbor it is 0, via another neighbor it's nothing. If it is null, then also it will consider it as 0. And remember, lower is always preferred in case of med, right? Next attribute will be external over internal. See, via IBGP neighbor it is what? Internal. Via EBGP neighbor via BT it is having external. See, which one is preferred? That is why external is best now. See, check it out. So external will always be preferred over internal. Via R5 you see I is there, but via BT there is no I. Tell me, is there any problem now? So for R6 its best path is via what? BT. So it is necessary in BGP that you will always advertise your best path information towards your neighbor. You will always advertise your best path information towards your neighbor. So this time it is going to advertise this its best path information towards its neighbor, and it is having neighborship with R1. So it will advertise this information towards R1 that you can reach these prefixes via me. That is why R1 is receiving these prefixes from both neighbors. Because for R5 its best path was via BT. For R6 its best path is also via BT. So both of them are advertising their best path information towards their neighbors R1. And R1's best path is what? Via R5. That is why this R1 is giving this information back to R6, that you can also reach these prefixes via me as well. Hello. See, this time because you have configured route reflectors, right? So it is mandatory for BGP that it will advertise its best path information towards its neighbor. So for R1 its best path is via R5. So it is mandatory, it is compulsory for R1 to advertise its best path information towards its another neighbor. So yes, R1 is having neighborship with R6 as well, so it will also advertise this information towards R6. That is why R6 is receiving these prefixes coming from both neighbors, EBGP as well as IBGP. However, you can move back again on R5, and on R5 you will be receiving prefixes from its EBGP neighbors only, not from its IBGP neighbor. See, this is R5. It is receiving these prefixes coming from its EBGP neighbor only, Sprint US as well as BT. It's not receiving this prefix information from R1, because for R1 its best path is via R5 itself. So why will it advertise this information back towards R5? Hello. Try to understand. For R1 its best path is what? Via R5. So why will it be possible for, why will it advertise these prefixes information back towards R5? So it will advertise its best path information towards another neighbor, which was R6. So it has advertised this information towards R6, and R6 was receiving these prefixes coming from R1 as well as via BT. For R6 its best path was via BT. That is why it is also advertised its best path information back towards R1. That is why R1 is receiving these prefixes coming from both neighbors. Have you understood it or not? Good. Now let's move back again on our one. So I hope that you people have understood the BGP path selection and also prefix advertisement procedure. It will always advertise only and only best path information towards its neighbors. It has proved here. So this time this R1 is receiving these prefixes coming from R5 as well as R6. Best path is via R5. Now I want to make it via R6 based on weight. First of all, I will teach you weight because next stop I have already proved it, right? To become best path, it is mandatory that next stop address must be reachable. So this time weight is 0 via both neighbors. I want to make it, I want to define its best path via R6. So see guys, router BGP 65500 and via R6 configure its higher weight than via R5. Say 150.1.6.1 weight, because this is the neighbor's IP address, right? Weight is what? 1, because 1 is also higher than 0 and higher will always be preferred. Now do show IP BGP. Has your changes taken place? Have your changes taken place till now?
No.
Of course no. And in BGP, whenever you will do this type of configuration, your changes will not take place automatically. You have to say do clear, you have to clear your BGP neighborship, but if you clear your neighborship, it will affect CPU. So do one thing, configure do clear IP, clear IP BGP star in. Do not end your command with the star only. Call your in keyword as well, and this keyword and force to BGP to send a route refresh request towards its neighbors that retransmit all updates to me. It sends a route refresh message towards its neighbors. As I said that here we are not having only 4 types of messages, we are also having this route refresh capability, right? So we are having another type of message which is type 5 route refresh message in BGP, and its type is what? 5. So this time BGP will send a route refresh message towards its neighbors to retransmit all updates, right? And then you will see that its BGP table will get updated. Do show IP BGP, check it out. Via R6 for all prefixes. That's again wrong. That should not happen. Yes, see, its best path is via R6. That was desired, that was expected. But the problem is now the traffic for all prefixes will start to go via R6. However, we wanted to have load balancing. But again, the traffic for all prefixes will start to go via R6 only, not via R5. Vishnath, right? Understood or not, Balaji? So this is not good. This is not a good methodology to manipulate your BGP path selection actually, or this is not a good way to manipulate your weight, because if you are changing your weight per neighbor basis, it will change its weight for all those prefixes which are coming from that particular neighbor. But apart from it, you can also configure this command as well. First of all, say no, and then once again clear IP BGP star in, and see once again its best path will become via R5. This time I want to say that only for 102 and 103 I want to configure its best path via R6, not for first 2 prefixes. What will I do this time? That I will configure its best path via R6 only for last 2 prefixes, 102 as well as 103. So this time I want to change weight only for these 2 prefixes. So you can also change your weight for some specific prefixes only with the help of route map. So for doing that, do one thing, say IP prefix list. Let's say CCIE permit 192.168.102.0/23. Both of them, 102 as well as 103, will come in this range. Greater than equal to 24, less than equal to 24, because all of them are coming on /24. Is not it? So I have permitted all these prefixes inside this prefix list now. And now you do one thing, create one route map with the name of weight itself. Say permit what? 10. Match IP address, prefix list, and prefix list name was CCI. Now say set weight. How much? 10 will be enough, right? Or 50? Let's say 50. So now it will set weight for all those prefixes which will match with this prefix list. So only last two prefixes will match with this prefix list. What about remaining two prefixes like 100 and 101? They will not match with any statement of this route map, so they will be implicit denied. You understand? So what I want that it should keep on to receive all other prefixes from its neighbor R6 with the default attributes. It should not filter all other prefixes apart from 102 and 103, right? So to allow all others, you have to create another statement for the same route map, like route map weight permit what? 20. And then after say what? Of course nothing. Because match all is by default there. Match all is by default there. If you do not match anything under any route map, then definitely match all is by default there, right? I hope that you remembered all rules of route map, right? So definitely you will not say match, you will not configure any match command, and also you will not set anything because I want to receive all other prefixes with their default attributes. Now you do one thing, router BGP 65500. Now the big question is that for which neighbor you will apply this route map? For R5 or for R6, because it is having IBGP neighborship with R5 as well as with R6. So for which neighbor you will apply this route map? R5 or R6? See, if you apply it for R5, then via R5 its weight will be 50 higher, and by default its best path is via R5. By default its best path to reach all these prefixes is via R5 only. So why will you apply this route map for R5? There will not be any effect of this route map if you apply it for R5. So you do one thing, do apply it for neighbor R6. Route map name was in which direction? In or out? These prefixes are incoming prefix for R1 or outgoing? In. Simple. Now again, your changes will not be applied. So say do see weight has changed to IR6 but only for last two prefixes. Have you understood it now? Tell me. Now if you check its routing table, do show IP route BGP. Check it out. For first two prefixes its best path is via R5, whereas for last two prefixes its best path is via R6. So in this way you can manipulate your path selection with using weight. Now I said that weight is by default 32768 for self-advertised. So you can move on New York router and you can confirm it. See, and for self-advertised next hop will always be 0000. If your prefix is self-advertised prefix, then by default its next hop address will be 0000. Fine. Then after, I taught you that weight has local significance only. It will never be carried forward in your BGP updates. See, for R1 its best path is via R6 for last two prefixes. So this time it is not going to advertise this information back to R6 that you can reach it via me. No, because for R1 itself its best path is via R6 for last two prefixes only. That is why if you move back again on R6, for last two prefixes it is receiving them from BT only. See, this time it has stopped to receive it from R1. Because for R1 itself, its best path is via its best path is via R6 itself, right? So now let's move back again on R1. So because this time for last two prefixes its best path is via R6, so it will advertise this information back to R1 because it is configured as route reflector. So it will give this information back to R1. Sorry, R5 because we were already on R1, right? So for R1 its best path is via R6, so it will advertise this information back to R5. You see, show IP BGP. Last two prefixes are coming from three different neighbors now. Only last two prefixes. Hello.
Yes.
But weight is still what? 0. You can see that. Weight is still what? 0. It means R5. However, for R1 its weight was 50. But when R1 advertised those prefixes in the direction of R5, again it has been configured as 0. It means weight is not part of BGP updates. So whenever BGP will advertise any update towards its neighbor, it will never include weight. Even we can check it out, right? What can we do? I will capture this link here, and then I will move back again on R5 and I'll say clear IP BGP neighbor 150.1.1 and then this particular neighbor. So it has to retransmit update. This is route refresh came from R5. Route refresh masses came from R5. See, route refresh type is what? 5. This is forwarded by R5, and then update is given by, tell me, R1 to R5, right?
Yeah.
See, is there weight
No.
under path attributes? Of course not. I'll be discussing it later on, that what is the meaning by cluster list and what is the meaning by cluster ID,
Sorry,
originator ID. What?
marker.
What marker? This is, I don't know what was that actually. Might be it is for fulfilling the minimum requirement of the packet or something like that. Fine. So you see path attributes and NLRI is there 102 as well as, see, because R1 was advertising only 102 and 103 only in the direction of R5, because for R1 only for these two prefixes best path was via R6. It's not it. So it has also proved now. Now then after, see, move back again on R1. So it has proved that this weight has local significance. It will never carry forward it within BGP updates. Fine. Then after, let's talk about local preference. First of all, do one thing, router BGP 65500, remove it. And say no route map name was weight. And so prefix list will still required over there, right? So IP BGP. Again, its best path for all prefixes is via R5. Check it out. Is not it? Once again, its best path have been configured via R5. Fine. Then after, once again there is a problem. So previously we learned that how to manipulate your path selection with using weight. And one more thing, with using weight you can modify only and only outgoing traffic path selection. You can manipulate only and only outgoing traffic path selection. Because prefixes were incoming, so definitely traffic will always be outgoing. That's why I said that with using weight you can manipulate only and only outgoing traffic path selection. So previously for R1 its best path to reach all these prefixes was via R5, but this time it's via R6. Sorry, I mean previously it was via R6 for 102 and 102 and 103, but once again after removing this weight, you can see that again its best path is via R5 from R1, right? So as I said, weight has local significance, so I have proved all these things. Next is what? Local preference. So you have also understood that weight will be used just to manipulate your outgoing traffic path selection. In same manner, you can use local preference. The very first thing, I mean the very first negative point about weight is that weight is Cisco proprietary attribute. Weight is Cisco proprietary attribute. That is why you can configure weight only on Cisco's devices, not on any other vendor specific device, right? So that's why there is local preference as well. You can also modify, you can also achieve the same task with using local preference, but remember local preference will always be carried forward within BGP updates within a single AS. So whenever you will advertise any update towards your IBGP neighbor, then you will always include local preference, as we saw.
So local preference कब करें?
नहीं. Fine. So अभी कर लो. Now let's move back again on R1. Show IP BGP for all prefixes. Its best path is via R5. Let's make it via R6 with using local preference this time, right? So see, from R6 it is receiving its local preference as what? 100, which is by default. So you do one thing, move back again on R6 now. Router BGP 65500. You can also configure this command BGP default local preference in place of 100, make it 100. This is the way in which you can modify the default local preference of a device. So this R6 was receiving prefixes coming from eBGP neighbor with default local preference. I mean not with default local preference, actually with null local preference. But this time whenever it will advertise these prefixes in the direction of R1, it will add its local preference as 101. So this time if you move back again on R1, see show IP BGP, what is this? 101. Because whenever R6 will advertise any update in the direction of R1, it will set its local preference as 101. You understand? Just give me 1 second please. Hello? Fine guys? So see, its best path is now via R6, and this time see R1 does not have those prefixes in its BGP table via R5 as well. I mean it does not have any alternate path this time. Why? This is the big question mark now. You know why? Because whenever R1 came to know that okay, its best path is via R6 to reach all these prefixes and local preference is what? 101. It will also advertise the same update in the direction of R5 as well. It will inform R5, and R5, see, move on R5 now. Show IP BGP, check its BGP table. Now it is receiving all these prefixes from 3 different neighbors. 2 are eBGP neighbor, 1 is what? IBGP neighbor. 2 are eBGP neighbors, 1 is IBGP neighbor. See, check it out. Even for R5 itself, its best path has been configured via R6. You know why? See, check its local preference now. This time it is modified 101. So from eBGP neighbor, its local preference is null, which will be considered as 100. So it is not comparing this time local preference or external internal attributes. Do you remember that previously external was preferred over internal, but this time your election is not going up to external and internal. Based on local preference itself, this R5 has defined its best path. This R5 has elected its best path. That's it. Is there any question now? That is why for R5 itself, its best path is via R6, and that is why R5 is not giving this information back to R1 now. Because for R5 itself, its best path is via, R1, because it got this information from R1. That is why it is not advertising these prefixes back to R1. That is why R1 is not having these prefixes by R5 in its BGP table. You understand what I mean to say now? Hello, have you understood it or not? So from this AS now, from this entire AS 65500, whenever any user will transmit data, will transmit traffic in the direction of all these prefixes like 100.0, 101.0, or 102.0, or 103.0, it will always go via R6. Even from the lane users of R5 as well. Understood or not? So in this way you can modify its default local preference. Now that's good. Now let's move back again on R6 and let's try to make it once again 100, which is by default, right? So once again you will see that for R1 its best path will become via, see, R5 once again. And if you want to modify this local preference only for 2 prefixes, then use route map. And we can also modify it on R1 itself. It is not always necessary to modify it on R6. You can also modify it on R1. Because for R6 we know very well that its best path is via BT itself. It's BT. See, external is always preferred over internal. Now you do one thing, move back again on R1, and you can also, because we are already having prefix list for last 2 prefixes and name was CCIE, right? This time I'm gonna to create one route map for local preference actually only. Permit 10, match IP address prefix list was, and then set local preference is what? (101), which is higher than, but other prefixes will be implicitly denied. So to allow all others, you have to create a another statement for the same route map with higher sequence number. Do not match anything, do not set anything. And then where will you apply? For which neighbor you will apply it one here? For R6 or for R5? Via R5 it is already having best path. So you are required to make it its best path via R6. So you have to apply it for R6 only. So route map name is what? In which direction? For last 2 prefixes now. Even it does not have alternate path. You know why? Because it will inform to R5, and for R5 itself its best path to reach all these 2 prefixes will also become via R6. Is not it? So in this way you can modify your local preference. I will also let you know some other features, some other ways to configure your local preference, but in tomorrow's class. Still this local preference is not completed.